computer science and programming language Java. Today we will discuss a way to sort objects in an array, and the name or the title of this kind of sort is insertion sort. And why does this kind of sort has this unique and a bit strange name? Well, in this kind of sort, what we do is, as we receive or build an array that includes perhaps objects, actually the array includes references to objects, not the objects themselves, but nevertheless we receive or we build ourselves some array that includes objects, and these objects are, when we have this array at hand, we can see that all of those objects are they are located in some way that takes use of their index. So we have the first object in index number 0, the second object in index number 1, the third object in 0 number 2, and so forth. So as we receive this array or build it ourselves as part of our initial code, we can see that those objects are just kind of randomly and with no specific significant order. They are located in their respective indexes in their array. And what do I mean by that? When we take a look at the objects that are in this array, we may find that those objects, whatever they are, they have some internal quality or something that is unique about them that has some kind of way to measure it or to give a number to it. For example, we may have objects that have a certain height or a certain width, or maybe a certain weight in kilograms, or maybe it's an object that we can say that this object has some kind of speed, or any other quality, or a price, or any other quality that is measurable. And so looking at this internal quality of the objects, we can say that we may sort those objects according to that specific quality, and to sort them and to place them in a new location that is in accordance to this quality, from in ascending or in descending order, from the highest to lowest or from lowest to highest, and so on. So this is what we are doing when we're sorting objects. So in this case of this example of the sort that is named insertion sort, as an example, I will take a situation from nature. Let's look at the wildlife nature, and let's examine a pack of chimpanzees, of monkeys. And as perhaps many of you know, in a group of chimpanzees, they have a certain internal order between themselves, between the male chimpanzees. When the highest ranking monkey, he is sometimes called the alpha male, the highest ranking monkey, this monkey has the most dominance, he's the most powerful, and he has the most access to food and also to the females in the group. So behind this alpha male monkey, the other male monkeys, chimpanzees, has their own order, and every male in this pack knows his respective order when he's compared to the other males. So we have this kind of a ranking system. It's called a dominance hierarchy. And interestingly, when this thing was studied, it was shown that the monkeys, they don't need to constantly fight with each other endlessly. it is enough that the monkey, let's say a new monkey, wants to find his way into this ranking system. The new monkey may only make a few fights, beginning from the top and from the alpha male. And as he loses to this alpha male, and he then goes ahead, if he loses to the alpha male, he goes ahead and he has another fight with the male that is just beneath the alpha male. So, and if he wins that altercation, that fight, then the new monkey knows exactly where he stands. He's below the alpha male, but above the monkey that was previously the second one behind the alpha male. But if the new monkey loses the fight also to that other monkey that was just the one behind the alpha male, then the new monkey continues the fights, another fight and another fight and another fight, and as long as this new monkey is continuing to lose, then this new monkey is going down in the hierarchy until the minute that, thank God, this monkey wins at last some other monkey, and then after he won, this new monkey knows exactly, and not only he knows, but also all of the pack knows exactly where this monkey stands. This new monkey is going to be beneath all of the other monkeys that he lost to, but he's going to be above the monkey that he just won over. And we know that the place that now, the new place of this new monkey is going to be, his spot will be inserted exactly there, exactly after all of the monkeys that he lost to, and just above the monkey that he just won over. And this is going to be his new spot in this pyramid, in this hierarchy. So this is, now you know where the word insertion comes from. This inserting aspect of putting the new monkey just in his respective location, in his location in the hierarchy, this is where the word insertion comes from. And this act of inserting that monkey exactly in his new space in the hierarchy, pyramid, and the dominance order. So, and this is exactly what we do. So in this algorithm, in this kind of sort, what we do, we have two loops. The outer loop, the for loop of the outside, is the loop that all the time adds another monkey. As we proceed in our array, we all the time add some other monkey, another monkey that was not doing the fights quite yet. Now this monkey wants to challenge the alpha male, and we each time give another monkey the chance to fight the current alpha male, the current highest ranking monkey, and then have all of the other subsequent fights if he loses, until he stops losing and find his new location. But this addition of each time giving another monkey the opportunity to begin this cycle of fighting, so each time we give another monkey this chance to start all of these fights, this is the outer loop, and this outer loop will go over all of the monkeys in the array. It will not begin from the first monkey, because if it will begin from the first monkey, the monkey from index 0, it actually has no merit in it, because it's just one monkey and he has no one to fight with. So currently, if we're just looking at this monkey in location 0, in index 0, so he has no one to fight. He's the only one that exists. But so this outer loop, it actually begins from the second monkey, the monkey at index 1. And this monkey at index 1 will fight the current alpha male, which is the only male that existed so far, which is the monkey at index 0. So this loop, outer loop, that keeps on adding monkeys and giving each monkey the opportunity to begin in this sequence of fights, this outer loop begins at index 1 and not index 0, because what it's going to do is the first fight is actually going to be when the monkey in index 1, which is the second monkey, will fight the monkey that already exists in index 0, which is the first monkey. So the outer loop will proceed until it finishes all the monkeys, until the last monkey in this array. And this was the outer loop. Now the inner loop is projecting each monkey that is now being in this he's striving to find his location in the hierarchy. So when now we're dealing with a certain monkey and we're using his index to know which monkey we are referring to. So now looking at the monkey that we are now dealing with, so the inner loop is actually all of those repetitive fights that this monkey is now doing all over the pack of monkeys to try to establish his location in the dominance hierarchy. So in this inner loop, we are going to let the monkey start fighting, and we will let him start fighting the monkey that is currently the highest ranking monkey, the alpha male, the one that is the most dominant, which is going to be the monkey just next to him, next to the monkey that is now making the fight, the new monkey. So our loop is going to go sort of backwards. The monkey is going to start by fighting the monkey next to him, which is the most strong monkey. And the fights will continue, another one, as long as the new monkey is losing. As long as the new monkey is losing, he is weaker, he is not strong enough as the one that he's fighting against, the monkey will keep on going down and down and down in the hierarchy and this pyramid of strength, and until at last the monkey will at last win one fight. And then the monkey will know that this will be his new location, behind all of those that he lost to, but above the one that he finally won against. So this loop will continue under two conditions. This loop of more and more fighting of that same new monkey, this loop will continue until at last this monkey will at last win against some monkey, or at the case that the new monkey finished and lost to each and every monkey in the pack. So if there are no more monkeys left, and it's actually the case where the monkey that we're now dealing with is the weakest in the pack, he's going to be behind and at the bottom of all of the other monkeys, he's going to be at the bottom of the ranking system. So in this case, when we actually, this monkey finished to fight with each and every monkey in the pack, he actually finished all of the array of monkeys, he got down to 0, no more monkeys left, he lost to each and every one of them. And so in this case as well, there is no more fighting to be done. So we will finish this inner loop there as well. So we can see that the inner loop, which is usually and many times a while loop, it's not mandatory, it can be other kinds of loop, but usually it's a while loop. So this while loop has more than one condition in it. It's either it will continue as long as there are monkeys to fight. The number of monkeys is more than 0, and you did not reach the monkey at 0 at index 0, or it will stop if the monkey at last won someone, and we can stop the fighting because now the monkey knows exactly where he should be located. So now, after we saw the outer loop and the inner loop, and we discovered where each monkey should be inserted in this hierarchy at his turn, so how do we make this insertion? So as we know, in computer science, there is a big emphasis of not spending memory to waste. So we cannot make a maneuver of just pushing all of the monkeys to the left and to the right and making a free spot to the new monkey to insert himself there. We cannot just do that casually because we don't have in the array an empty space to do that. And actually, when we think about making space to the new location of the monkey in his new and updated place in the dominance hierarchy, actually, as we move each and every monkey that was being fought against to the right, it kind of actually overrides or kind of erases the memory of the monkey that was on its right as the monkeys move right to make space to the new location of the monkey. And this is all fine, except the fact that when everybody is moving to the right, it could be also to the left. I'm just using right just as an example. But when everyone is moving to the right, the monkey that was at the most at the right, which is right now the monkey that we're dealing with and that making all these fights, he will be erased. He will have no memory left of him. And then we'll be in trouble because now that we know at last where his final place is going to be, we will not have him anymore. He has been overwritten by the other monkeys that kind of moved all over him and kind of erased his existence. So what we do in this kind of situation is a technique of swapping, which it's commonly used to make a switch of places from place to place. And what we do is we designate a specific location outside of the array, and we use it as kind of a temporary spot just so this swapping can take place. So what we do is that before we begin to let our monkey to do all of these fightings, each time another monkey, so what we do is before this new monkey begins to fight with everybody, so we copy his memory, we copy his information to a different location outside the array. We call it some kind of name such as temporary or key or something of the kind, and we keep this monkey's memory information there. And then when we at last know where the location of his position should be, we just copy from that temporary location to that final designation. And this way we did not lost the memory of this monkey. And I also saw that there's a different technique, which I also saw on the internet in some example of insertion sort. And in that other example, I also see that the programmers sometimes do it a bit differently. They don't just copy the memory of this one monkey that is now fighting everybody and just put his memory in some temporary location until all of the fightings are finalized and we know where is the monkey's location, and then just copy that location, that memory to that location. But I saw a different approach, which means that there are many swapping being done over and over and over again. So like each fight has its own swapping with its own temporary location and memory of that specific monkey that is now making a specific fight. So that is an approach that involves a lot of swapping, but I also see it in the internet as an example of a code of insertion code. So I just wanted you to know that this approach also exists. So I hope you find this information about insertion sort interesting, and thank you for watching.